inventory management. Learning objectives. By the end of this topic, you will be able to define the concept of inventory management, list functions and limitations of inventory, explain the inadequate control of inventories and inventory costs, describe the ABC analysis and VED analysis, illustrate economic order of quantity and assumption of economic order quantity, interrupt P systems and Q systems. Introduction. Stores management. Inventory control is a systematic procedure for ensuring the availability of items necessary to meet the production requirement at optimum cost. It is concerned with the procurement of raw materials and components and their supplies to the production department. Ensures availability of materials at every stage of production. A production without any interruption or delay necessitates a mechanism of inventory control and stores organization. Inventory control directly influences cost of production due to internal and external factors such as purchase of materials, vendors, offers and terms, market availability, transportation problems and credit terms. External factors influence cost and delivery dates. Inventory management is mainly classified as effective running of the stores, stock control of items. The purpose of inventory stock: to have a buffer stock in between input and output, to avoid time lags between manufacturing and transport operations, to ensure against delays in deliveries, to meet the fluctuation in demand and product states arising from sudden increase in output due to market demand, take advantages of discounts on large purchase, to maintain control over quality of finished product. Inventory at WAL-MART. Knowing what is in stock, in what quantity, and where it is being held is critical to effective inventory management. The entire supply chain is incorporated for an effective inventory management. The firm is implementing radio frequency identification (RFID) technology in its supply chain. When passed within 15 feet of a RFID reader, the chip activates and its unique product identifier code is transmitted to an inventory control system. Inventory management. Inventory. Inventory system. Click each tab to learn more. Inventory. A physical resource having rupee value that a company holds in stock with the intent of selling it or transforming it into a more valuable form. Inventory system. A set of policy and control that monitors levels of inventory and determines what level should be maintained, when stock should be ordered, and how large orders should be maintained. Functions of inventory. Functions of inventories. It makes possible the smooth and efficient operation of a manufacturing organization by decoupling individual segments of total operation into the following: purchased part inventories, inventories of parts and components, finished goods inventories. Inventory includes raw materials, components during process, finished and packaged components, distribution of components, maintenance, repair and operation goods, stock in order to meet an unexpected demand or distribution in future. At the same moment, the functions of these inventories are carried out at given time. While describing specific functions, the following must be kept in mind: decoupling inventory, cycle inventory, demand-related inventory, pipeline inventory, Buffer inventory. Fluctuating price inventory. Click each inventory tab to learn more. Decoupling inventory. The important material is waiting for the process so that the process itself is most economically used, and it is found on batch which decouples in one process to other. Cycle inventory. The decision is to manufacture a quantity of products which are related to cycle inventory. To avoid the loss of process capacity and the setup costs are reduced. Demand-related inventory. The general idea is to stockpile inventories during less demand period and sell during the high demand period. Umbrella stocking in winter and selling during summer and rainy seasons. Pipeline inventory. Pipeline inventory is used when a factory decides to subcontract one process to an outside firm at some time during the total process. Buffer inventory. The general idea of buffer inventory is change the supply variations in demand. The average demand decreases when higher levels are held in a company. Fluctuating price inventory. Inventory that is carried as a cushion to protect against forecast error. Businesses usually hold inventory to avoid from the ever-fluctuating market price of inventories. Thus, by having efficient and good inventory system, businesses can control their inventory cost. Objectives of inventory control. Produce sufficient products to avoid excessive carry costs plus excessive stocking costs. To minimize ordering or setup costs. Purpose of holding stocks. To have better stock between input and output. Improve customer service. To avoid time lags between manufacturing and transportations. To meet the sudden or unexpected increase of market demand. Save transportation costs. To avail advantages of discounts given on bulk purchases. To be prepared to face scarcity of raw materials in the market. Unexpected events, labor strikes, natural disasters, surges in demand, etc. Predict stock of finished goods to avoid stockouts. To maintain independence of supply chain. To maintain control over quality of finished products. Helps in keeping the investment advantages of inventory, obsolescence losses to minimum. Adequate protection against uncertainties of supplies in demand. Availability of capital for other operations. Adequate customer services. Even out the workloads on the shops in the fluctuating demands. Better utilization of stocks by facilitating inter-department transfers. Provides control over losses and pilferage of materials. Limitations of inventory. Non-value added costs. Complacency. Inventory deteriorates, becomes obsolete, lost, stolen, etc. Lock-up capital or an inventory can be invested in more profitable operations. More storage space, additional labor, additional insurances and taxes must be incurred. Changes in the prices of procurement. Inadequate control of inventories. Understocking results in missed deliveries, lost sales, dissatisfied customers, and production bottlenecks, ideal workers on machines. Overstocking ties up funds that might be more productive elsewhere. Inventory costs. Ordering cost. Carrying cost. Shortage or stock out cost. Click each cost tab to learn more. Ordering cost. Cost of placing an order with a vendor is ordering from the plant. Annual ordering cost is equal to number of orders placed in a year into cost per order is equal to annual demand or order quantity into cost per order. Carrying cost. Cost connected with material, obsolescence, deterioration. Capital cost, intersectional capital, land and building equipment. Storage space cost, rent, taxes and insurance on buildings. Inventory service cost, taxes on inventory, expenses connected. Inventory rise costs. Annual holding cost is equal to average inventory level into holding cost per unit per year is equal to order quantity by 2 into holding cost per unit per year. Shortage or stockout cost. Back ordering. The cost associated is a function of the cost per unit time. That is, after how much time can you satisfy the customer. Lost sales. A customer walks into a store and he does not find a particular shampoo of his choice. He just walks away from it, so that sales is lost. Economic order of quantity. The formula for the economic order quantity EOQ is derived by developing an expression for total annual inventory management cost, then taking its derivative with respect to quantity Q to find its minimum point. EOQ equal to average monthly consumption into lead time in months plus buffer stock minus stock on hand. A economical order quantity is equal to EOQ. Carrying cost is equal to ordering cost. EOQ is equal to square root of 2DS by IC. D is total annual demand in units. S is setup or procurement cost per order. I is carrying cost per unit carried, expressed as a percentage of unit cost. C is cost of individual item cost by unit. Assumptions of economic order quantity. Only one product is involved. Annual demand is known. Demand is even through the year. No constraints on lot size. Each order is received in a single delivery. Decisions for items are independent from other items. Inventory level is equal to 0 when new order just arrived. There are no quantity discounts. Orders are placed at the right time to avoid stockouts. Balance in inventory levels. Balance in inventory levels answer the following situations. When should the company replenish its inventory, or when should the company place an order or manufacture a new lot? How much should the company order or produce? Inventory cycle. Total cost is equal to annual carrying cost plus annual ordering cost. Reorder level. Stock level at which fresh order is placed. Average consumption per day into lead time plus buffer stock. Lead time. Duration time between placing an order and receipt of material. Ideal time 2 to 6 weeks. Classification of inventory control techniques. Inventory control techniques. ABC analysis. VED analysis. A. Items. B. Items. C. Items. ABC, HML, VED. ABC analysis. ABC classification. Pareto principle. ABC analysis classify the items in store based on demand of stock. Continuously monitor the stock according to demand pattern. Classify the items into different categories. Apply flight control on selected categories of items. The steps in computing ABC analysis are: determine the annual usage in units for each item for the past 1 year. Multiply the annual usage quantity with the average unit price of each item to calculate the annual usage in US dollar for each item. Item with highest dollar usage annually is ranked first. Then the next lower annual usage item is listed till the lowest item is listed in the last. Table 1 shows ranks of the items according to the annual usage in US dollar for 10 items. Arrange the items in the inventory by cumulative annual usage dollars and by cumulative percentage. Categorize the items in A, B, and C categories. A items: tight control, complete and accurate records, frequent review, strict and closer watch, low safety stocks to be managed by top management. They are about 10% of the items, accounts for 70% of the annual consumption value of the items. B items: good records, regular review, moderate control, strict watch and control, managed by middle-level management. They are about 20% of the items, accounts for 20% of the annual consumption value of the items. C items: ordering control measures, minimal records, high safety stocks, periodic review and reorder. ABC: analysis is based on their consumption value. HML: analysis is based on unit value. VED: analysis is based on criticality of inventories. Once ABC analysis has been done, the following broad policy guidelines can be established in respect of each category. ABC analysis. Example 1. The following inventory data is given. Compute the annual usage for each item. Compute the total annual usage. Compute the annual usage percentage for each item. ABC analysis. Example 2. In the table below, arrange the items in order of descending annual usage percentage, largest to smallest. Then compute the cumulative annual usage percentages. Finally, classify the items as A items, B items, or C items. VED analysis. VED analysis is alone to determine criticality of an item and its effect on production. It is mostly used for spare parts. Though negligible in monetary value, may be vital for running the plant and constant attention is needed. It finds out which materials and parts are valuable, which are essential, and which are desirable. Inventory items are classified on the basis of their criticality to the production process or other services. V. Vital items without which the production process would come to a standstill. E. Essential items whose stockout might cause temporary losses in production. D. Desirable items which are required but do not immediately cause a loss of production. This is also essentially meant for a sizable reduction in inventory. It is a subjective analysis based on critical value and shortage cost of an item. Category 1. Needs close monitoring and control. Category 2. Moderate control. Category 3. No need for control. Other analysis. HML analysis, SDE analysis, FSN analysis. Click each tab to learn more. HML analysis. HML analysis, similar to the ABC analysis, except that the items are classified on the basis of unit cost rather than their usage value. H stands for high cost per unit. M stands for medium cost per unit. L stands for low cost per unit. SDE analysis. SDE analysis works on the criteria of availability of items. S stands for scarce items. D stands for difficult to obtain. E stands for easily available. FSN analysis. FSN study may be made to weed out, discard or remove unwanted materials and parts. It is based on the consumption pattern of items. F stands for fast, S stands for slow moving, N stands for non-moving materials and parts. The speed classification helps in the arrangement of stocks in the stores and in determining the distribution and handling patterns. Further, it will automatically reduce inventory costs. Say a part or material has not been issued within a period of 3 years, can be completely weeded out. A part moves sparingly within this period. Its stock can be substantially reduced. Fast-moving material, however, pose no such problem. P systems and Q systems. Implementation of purchase inventory model. The practical method of purchase model of inventory can be classified into fixed quantity system, Q system, fixed period quantity system, P system. In cash system, the following cases exist: varying demand and constant lead time, constant demand and varying lead time, varying demand and varying lead time. P systems, Q systems. Click each systems tab to learn more. P systems. Fixed order period system. Not suitable for A class items. Extremely useful for B and C class items. Desired inventory level is equal to buffer stock plus safety stock plus reserve stock. Stock positions are reviewed once in a fixed period, and order is placed depending on stock positions. The frequency of reviews varies from firm to firm. Some buffer stock is necessary for increased consumption or increase in lead time. Single bin system. The concept of a P system can be translated into a simple visual system. A maximum level is marked on the bin and inventory is brought up to the mark periodically. In this system of inventory, the stock position is reviewed once in a fixed period and an order is placed depending on the stock position. Unlike a fixed quantity in the Q system or inventory, the raw period is approximately equal to EVQ by D. The desired maximum inventory level is fixed as the sum of the average demand during average lead time plus review period. Variation in demand during average load time plus review period, and the average demand during delays in supply. A schematic representation of this model is shown in image. Advantages: ordering and inventory costs are low. The suppliers offer discounts at sales or guaranteed. This system is good for materials for irregular or seasonal usage whose purchase must be planned based on sales estimates. Limitations: because of difference in usage rates, supplies may not be ordered until the succeeding review. There will be need for an early order if usage increases. Actual order quantities may deviate substantially from the optimum quantities. Q systems. Fixed order quantity system, and also called two-bin system or perpetual inventory systems. Reorder point determined by buffer stock, reserve stock and safety stock. Suitable for A-class items. Requires continuous review of inventory. Buffer stock. Average demand during average lead time. Reserve stock. Variations in demand during average lead time are known as reserve stock, depend on service level. Safety stock. Average demand obtained through multiplying average demand for maximum delay and probability of delay. Two-bin system. A visual system version of the Q system in which an item's inventory is stored at two different locations. Advantages: each item can be produced in most economical quantity. Purchasing and inventory control can be made to the items that are needed when required. Limitations. At regular intervals, suppliers are not convenient when orders are placed. The components can be grouped and ordered at a time, since reordering points occur irregularly. This system assumes stable usage and definite lead time. When they change, new order quantity and new order point is fixed, which is cumbersome. Comparison between Q systems and P systems. Comparison between Q systems and P systems is shown on the screen. Q model fixed order quantity system and P model fixed time period reordering system is displayed on the screen. Summary. Let's summarize the topic. Inventory holds raw materials, in-process components, finished goods, packaging spares in order to meet unexpected demand or distribution in future. A physical resource that a company holds in stock with the intent of selling it or transforming it into a more valuable form. Pipeline inventory is used when a factory decides to subcontract one process to an outside firm at some time during the total process. Numerical problems. An industry estimates that it will sell 10,000 units of its products for the following year. The ordering cost is 100 rupees per order and carrying cost per unit per year is 25% of the purchase price per unit. The purchase price per unit is 40 rupees. Find EOQ, number of orders per year, time between session order.